Everyone, glad you're here. I think I'm going to abbreviate the introduction accordingly. I was going to talk about what a Shop Talk webinar is. It's a chance for our research and consulting teams to work together and cross-pollinate ideas. We decided to open this up to all of you to join in the discussion. If we're going to learn, we might as well help other people learn as well. Eckerson Group Research Consulting Advisory Services. These are some of our upcoming research reports and webinars. These are some of our recent consulting clients. I'd like you to join in the discussion. So click the QA button below and post your comment or question. And we'll post a recorded version of this in a few days and send you a link to all the slides. This is our illustrious panel. This is of folks from our research team, you can see above, and folks from our consulting team, you can see below. And we have a special guest, Nick Elprin, CEO and co-founder of Domino Data Lab. Nick's been a long-time veteran in this space. We thought he could add some interesting perspectives and viewpoints on it. So welcome, Nick. Here's the agenda. We're going to jump right into this, starting with a poll of all of you. So Sarah, if you could launch the first poll question. We want to know which best describes your role. Is it a data leader or manager, an analytics leader or manager, data scientist or analyst, data engineer, architect, governance officer, or other? You could fill that in. That will help us tailor our remarks a little bit better today. Okay, Sarah, I think that's going to be enough. If you could post the results, that would be good. There we go. A lot of others, but a lot of data leaders, analytics leaders, only a sprinkling of data scientists, and a few more data engineers. That's good. So let's do our next poll. Which best describes your organization's use of AI or ML? Is it mature, somewhat mature? You're in your initial rollout, you're in planning, or you've got no plans? So again, this will help us understand who's attending and so we can speak to you better. Okay, Sarah, why don't you close that and show the results? Most people in their initial rollout. That makes sense. People tuning in to get more education to make sure they do things right. So that's what we're going to talk about today, how to do things right. Because if you don't think about governance before you start hiring data scientists and building out data pipelines and models, you might be in a little bit of trouble. So let's close that, Sarah. And I'm going to turn this over to Kevin to provide a little context before we jump into the panel discussion. So there we go. So Kevin, it's all yours.
All right, thank you. So let's start with some basic definitions. And I think, as Wayne emphasized, we have some real experts on the panel who have come at this from a lot of different directions as practitioners and consultants, as vendors and researchers. So I'm looking forward to discussion of even some of the points here. But
and Kevin has some Wi-Fi issues, so I will pick up the slack here. Basically, this slide's to define AI, software that mimics human cognition, predicts, classifies, and recommends things, and uses rules, statistics, machine learning, deep learning to do that. Machine learning really is a subset of AI to discover patterns in data, define relationships between key data inputs, can be supervised or unsupervised. And the slide really shows that you really need data governance to embrace and encompass all of that. A program that manages your data assets, oversees the people, process, policies, and standards, and enables business activities while controlling data usage and minimizing risk. So balancing risk and access is really important in AI, ML, as well as other aspects of analytics. Kevin, are you back with us?
I think I am, Wayne. Okay, apologies.
I just covered this slide for you, so.
Thank you very much. Okay, so you're going to see us use the terms AI/ML. And to reiterate what Wayne said, ML is a subset of AI. It's the most common implementation among a lot of the enterprises that we're working with. And there's kind of a collision right now with data governance programs. So if we go to the next slide, what could go wrong? Plenty. And the fundamental risks are that you could have privacy breaches. Obviously, PII, or personally identifiable information, is getting a lot more scrutiny, rightfully so, for business reasons and also for legal reasons. If you look at GDPR, if you look at CCPA in California, there are a lot of different ways in which organizations need to be careful about how they handle personally identifiable information. And models can come in here, machine learning models or AI models, they might be incorrect. They might well be correct or accurate to start, but models drift, data drifts over time, and so the accuracy can diminish. They could also inadvertently show bias. treating different ethnicities, different genders, and so forth differently. This opaque model is an important trend to keep in mind, and that is that you need to be able to clearly explain what a model is doing with, for example, PII, personally identifiable information, in order to demonstrate compliance with different requirements. Final point here is that illegality is also a risk. You could well have a model that is inadvertently not just out of compliance, but doing things with PII that raises concerns legally. The business results are somewhat self-evident. You can alienate or upset customers. You can invite regulatory scrutiny. All this has a top-line impact. It has a bottom-line impact as well, because you might be, based on the recommendation of different AI or ML models, making investments, business decisions over the longer term that are misplaced. And fundamentally, it's critical for businesses to earn and retain the trust of their stakeholders, most notably customers. All these things are put at risk with an AIM model that is not carefully governed. So you want to do more good than harm. So we can go to the next slide here. There's a lot that goes into building an AI or ML model. And I want to quickly touch on the life cycle here, because each one of them has different implications for governance requirements. Data and feature engineering means you bring it together, you're ingesting and transforming all the input data. There's often quite a bit of it. You're labeling historical outcomes. In the case of supervised learning, you're also defining the features, the input data that matters most to a specific outcome or set of outcomes that you're looking at. The next phase is to actually build that model, selecting an ML technique, often downloading from a public open source library, a starter algorithm, and then training that algorithm on your data in order to produce a model that you deem sufficiently accurate and ready for production, which brings us to the model operational phase. And that's where things get really tricky, because you're implementing and starting to run these models live. At that point, keeping a close eye on performance and accuracy is critical. So throughout this, you need to start by looking at PII, ensuring data quality, ensuring the right safeguards for how you're handling that personal information. Obviously, building sufficiently accurate models, minimizing the risk of model bias is critical during the development phase. And then the ongoing vigilance, you really can't overemphasize the need to this, because models will degrade. And it's critical to keep an eye on that, and throughout the process, demonstrate compliance with different internal policies and regulations. So there are a lot of different stakeholders, and we've got a number of them here on the call. Data scientists are going to serve as quarterback here. They need to get coaching by the business owner throughout. They're going to work with data engineers in the data and feature engineering phase. They're going to hand off a model, but still work alongside them to the machine learning engineers that are going to take that model into production. Throughout this, they need to engage with governance officers to make sure they're keeping a close eye on things. So this is a view of the life cycle, and it's kind of a reference point as we go through the questions and invite insights from folks on the panel. So Wayne, I think I'll hand over to you, and we can dig into our first question.
Yeah, great, Kevin. That was a great context setting, and now we're ready for discussion. And I didn't get a chance because of the technical difficulties to really introduce our panelists, but they are very experienced in this space. You know, Steve and Kurt have been data scientists for many, many years, and now lead teams and consult in that space. Nick obviously runs a data science company. Sanjeev has studied these types of tools, and so on and so forth. So I'm really looking forward to what these folks have to say. Now, we've started with 5 questions that we'll go through, and so let's kick it off. So the first question to the panel, how do you adapt your data governance program to address AI and ML initiatives? Now, to start a discussion, I'm going to hand it over to Sean Hewitt, our data governance expert, to see what he thinks, because he helps companies build data governance programs. What do you think, Sean?
It's a great question, and we've seen a lot of organizations struggle with this. And what it comes down to is there's 2 primary goals that you have when it comes to governance. You need to govern the inputs, so what data is coming into the model. As we said in the other slide, there could be potential risks within that data, so personal information or other sensitive information that we need to manage to make sure we're not putting the organization at any additional risk of a privacy or security breach. Then also the processing that we're doing, is that legitimate processing, or are we crossing that line and That's where ethics and things like that come in. So it's a very thin line between what some people would consider acceptable processing when it comes to AI and ML and unacceptable. We're doing things that really infringe on people's rights, whether it comes to, the ethnicity, sex, anything like that.
So, Sean, I have to ask, should the AI governance be part of a data governance program, or should it be its own separate program?
Well, there's a huge overlap. So you have the data coming into it. So you have all of the data owners and data stewards and all of the policies related to that data that feeds the model. But then you have the model itself and governing the standards that are used within the models, and then the outcomes. How do you guarantee that you're going to achieve your objective with this? And what controls do you need to have to put in place? And what roles and responsibilities are required to really guarantee those outcomes? We've seen a lot of organizations put effort into building, sophisticated models, but then they're still not achieving their outcome. And part of that is because they don't have the governance in place to really drive that.
So it sounds like AI ML governance is maybe a working group of a larger governance program.
Exactly. So we need to build those synergies between the overall data governance program and what's happening within AI ML.
Okay.
One of the things that I've found is that there are often other parts of the organization that are responsible, maybe legally responsible for doing some of this governance. So credit policy at a bank or a financial institution, they often are the ultimate gatekeepers for a lot of these decisions that relate to making credit decisions. That obviously ties in with other parts of the governance in terms of what data you can use and so on.
Yeah. Even when it comes down to your business glossary, the definition, so the terms that may be used in your predictive model and the outputs there, just making sure they're consistent with what the organization is using in other areas.
And some of my most interesting experiences working in data science have been the work that we've had to do with lawyers. I remember one time it was just a month-long slog to be able to take a model and get it contorted into something that the lawyers were willing to approve. And there were the questions about legally okay versus mathematically okay. And we worked through those issues. I thought it was a challenging problem. The fact that we got through it meant that we were able to do something maybe that our competitors weren't able to do. But it was definitely something external to sort of the technical side of things. When the lawyers stepped in, it wasn't so much a technical discussion anymore.
Hey, Wayne, I'd like with another perspective here, sort of a different topic on this point. One thing that I think is really important for AI ML initiatives to be successful is to allow a high degree of experimentation and agility for data scientists and researchers. And that is often at odds with the perspective that data governance folks takes, where they're more interested in locking things down. And what I've seen work really well for companies to have graduated or degrees of data sources and have those be really well labeled and transparent about what degree of production use is this data allowed for or blessed for or certified for. And what that lets companies do is data scientists can achieve both goals, meaning data scientists can use data sources that are purely experimental. They've just, they've downloaded something from a website. It's a new experimental data source. They can test it out without going through hurdles and bureaucracy. But before a model built actually goes to production, you have to make sure that you're using data sources that have been fully vetted and certified for that. So I get, maybe the takeaway is it can't be a one size fits all, like all data has to be super, super governed. You have to give data scientists flexibility and agility.
I agree 100%. The goal is really to use the minimum amount of governance possible to manage the risk and facilitate that innovation and agility.
Yeah, it's interesting, Nick, you talk about these zones of refinement. That's usually what we recommend when we help companies modernize their data architectures. I'm wondering, Carlos, our resident data architect engineer, if you have any thoughts on this subject and how those zones might help organizations.
Yeah, I do. I think, because it's a direction we've been trying to take people in, even for non-data science initiatives, BI and other types of reporting and analytics, because the zone defines what the data is for the organization. And it's kind of a place to go to know that data is okay for me to use. It's published, it's approved. And I think data science needs to, adhere to some of those types of standards, so that once data falls into that zone, I know I can safely use it. Don't have to jump through a lot of hurdles to do that and get my project moving. And if I want data to be used that I publish, I can go through the process to get it into that zone, and there it is and available to use.
And that's where the metadata comes in handy as well. So if we've classified that data well, then people can quickly understand what data they can use and the level of sensitivity that's there and what they can do with that data and what they can't do with that data.
Great. Well, listen, great discussion on that point. Let's move on to the next one here. How do you build the right governance controls into your AI and ML lifecycle? Kurt, you want to tackle this one to start?
Sure. I think there's a lot of points along this life cycle where governance can play a role. And some of those roles are sort of good housekeeping, good practice to do. You want to make sure that your model doesn't crash, regardless of what the government might be telling you. It's just bad to have something go off the rails. But there are some more sophisticated or maybe subtle ways of evaluating the performance of a model. You may be making, for example, credit decisions. And if those credit decisions start to go wonky, the model may still be performing. They just may not be performing that well. So it could be that the economy has changed, the world has changed, the data has changed, or it could be that your model is somehow failing, but in a less than crashing way. And so you want to be on top of that. You want to make sure that the data that you're feeding into the process, you're allowed to use. You don't want to be using data illegally. You want to, when you develop your model, manage those work products so that they can be reused, can be shared, you can collaborate, and so on. So I think throughout the life cycle, you're going to have opportunities to incorporate governance into the process. The question is sort of how much governance do you do? You probably want to have some basic governance, and then you have some of these external forces, regulators, lawyers, credit policy people who are going to impose governance on this process. So that combination of types of governance, I think, will play a role. To Nick's point earlier, you want to make sure that you give everybody a chance to be exploratory. The thing that I've learned over the years is that data science is both a left brain and right brain activity. You need the creativity, you need the exploration to happen. If you're just about going from point A to B, you're not really going to find all the interesting things along that path. So you don't want to over-govern this process to take the creativity out of the hands of the data scientist.
Hi, this is Sanjeev. I want to jump in here because I want to mention the importance of the role of metadata in this space. We just talked about metadata a few minutes ago, but why it's important is because we need to be able to observe and understand the data as it's coming in from the data sources. And this happens for many, many different reasons why we need to control it. One of them is obvious, it's the data quality. You know, we see so many examples where the data is coming from IoT devices, and we know IoT devices can go bad and the data can be just fictitious. So we need some way to understand that there's a drift in the data, and hence what to do with that data. Do we quarantine that data or, or reject it? So there is that control. Then there is, understanding, observing the data to see privacy controls. Now, we may have said that, these features sensitive, and hence we're going to de-identify and mask them. But then somebody, to Nick's point, because we are allowed to explore, we may bring a third-party external data source, and all of a sudden we can now re-identify. So unless we had these controls, it's very hard. This is a reason why legal departments have such a hard time approving these models, because there are all these landmines that need to be addressed by, in a good governance setup.
I think that brings up a good point. The idea about investing in metadata is critical. You don't want to have the data scientists responsible for figuring out every piece of data within an organization. I remember when I worked for a bank, we had hundreds of versions of credit scores. And there aren't hundreds of versions of credit scores. There's a much smaller number, but everybody created their slight tweak to it, and they all had their own special sauce that they added. And so after a while, it became really messy. And finally, we introduced what I called at the time tough love, which is that we cut back on the number of credit scores that we had, but we committed to managing them so that when you accessed a particular credit score, you could believe in it. You knew that it was sourced correctly, that it was legally blessed, and that you could use it effectively. You didn't have to go out and create your own special version that you found somewhere else.
I think that's a really good point, Kirk, too, that complexity can be a real killer here. As you try to perfect your guidance, you make it so complicated that the person who's actually trying to use the tools ends up getting confused or just not understanding it. So, one analogy I've heard that's pretty good is to think of your data as kind of different materials in a nuclear power plant. Something like the plutonium, extremely powerful, very dangerous. It needs to be labeled as such. Other stuff, other materials you may have, other data you have, not so dangerous. And 3 to 5 levels of danger is probably sufficient to solve most of the big problems. Anything more than that, the complexity is probably going to kill the success of the program.
I definitely agree. And if they have that type of metadata so they can understand the data they're coming in and the level of risk that it represents, then we can provide them with a decision tree that helps them understand what steps they need to take from a governance perspective to appropriately manage that risk that's in the data. Then also, the outcomes, when we look at the quality of the model and things like that, what do they need to do to make sure that they are going to guarantee those outcomes, and providing them with that guidance in the frame of just formal guidelines or a standard is where governance can be embedded into that life cycle.
Right. I think this raises a really valuable point too. When we think about data governance in the space, sometimes there's the thought that we're locking things down, that it's preventing people from accessing. But this is sort of getting to that other half of it, right? That governance can facilitate and reduce complexity to make some of these projects more achievable as well. So it's not just about sort of preventing access, it's the facilitation of it as well.
Yeah. And the goal is to keep something like standards. If we're defining standards for this ML lifecycle, we want to keep it as light as possible. Just give enough direction to keep them out of trouble and save them some time in rehashing the same discussions over and over again. It really creates some agility once you set up those initial standards.
Yeah, great point. Sometimes they use the analogy that governance is like brakes in a car. And if you think about it, you cannot drive fast to get where you want to go if you don't have brakes, because either you'll careen off the road or you'll go so slowly you'll never get there, right? So those brakes, those controls really do help you go faster if you apply them properly. So I think that's a good segue to our next question. And we had a good customer question come in too that related to this question, which is, how do you assign the right roles and responsibilities to your cross-functional teams? And the user question was, what's the role of the business? How involved do they need to be in AI ML governance? So let's give this one to you, Steve, just to kick this off.
Wow, who wrote that question? That's exactly what I was thinking. So here's my take on it. The problem is not the problem. So you guys, it seems like the majority of folks are in the planning stage. So you understand AI, you got some ideas and some projects, or I'm sorry, you're in the implementation, just the beginning implementation stage. So you got some projects, you're probably getting some good results. You're probably thinking that what you really need to do is build some great AI model or some great AI application, and then it's just going to transform your company. That's not the problem. Your problem is actually getting anything kind of approved. And to me, the two enemies of kind of AI and using governance are the risk of a black swan event. Basically, that you got a great model, but for some reason it just miscalculates and you end up on the front page of the Wall Street Journal for whatever reason. And the other enemy is quivering inaction. He's kind of sitting in a corner, afraid to do anything. And so that's kind of like, to me, the real problem. It's not the brilliant AI or the brilliant models or whatever. So in terms of the roles for governance, number one role I would say is you need a business person who's on the hook, who has a business plan. AI shouldn't be viewed as magical. It should be operationalized, and it should kind of follow the same kind of processes you use in the rest of your business. Since we've got lawyers mentioned here, you don't want your governance or your lawyers to be your revenue prevention department. As Nick said, you need experimentation, but you also need some creativity depending on the size of your company, what you can get away with. But you don't hire a lawyer to tell you what to do. You hire a lawyer to say, what are your options and what are the risks? So I highly recommend having a business person very much involved. As you're building AI applications or even delivering models, view them each as products. A product is a little mini business. The amount of money you're putting into it, the amount of money you expect to get out of it, and what are the risks? It's not an either or, good or bad risk. You can actually put some calculations, some numbers around it to kind of evaluate the risk, what the risk of something going bad would be. So I'd highly recommend having a business person, very much involved. And obviously they've got to work with legal, regulatory. And I think we've already talked a little bit about the data portion of it and metadata and tagging the data. The nice thing about that is that if you can come up with the different types of data, you can dramatically simplify the governance, because then you just know if you're working with a type of data, it's risky or it's not, without having to look at a whole bunch of different rules that may be firing to tell you whether you're crossing some line. So it's a good initial pass to kind of simplify things. So I think those are kind of the major roles I see kind of for governance. And it's a little bit, I think, contradictory, because the first thing you think of for governance is your regulatory folks and your legal folks and your AI folks. But we're all in this to do business. So I think it's very important to have a person who's at least responsible for the business end of it involved.
Yeah, I might add that there are a number of stakeholders involved. To your point, Steve, you've got the ML engineer, data engineers, DevOps engineers in terms of bringing things to production. And so the data scientists and business owner need to work with them. But they're all getting a little bit out of their comfort zone with this stuff. And they all need to start to learn on the margin what the fellow next door is doing. So data scientists need to get a little smarter on data engineering. Data engineers need to get a little smarter on how to productionalize or help develop ML models. And then ML engineers also need to understand to some degree the domains of their peers. So it's important to instill a real sense of continuous learning. And I think some of the effective enterprises have data science council, have best practices that they try to instill across the organization, and a lot of ongoing knowledge sharing.
Let me throw out a question here from a current client of ours, a mid-sized healthcare firm that has about 6 to 8 data scientists. And what they really want to do to kind of kickstart this whole program is to create tiger teams, basically cross-functional teams of people of different roles. And I'm wondering if you guys, especially the practitioners on the panel, have you ever done that? Have you created these basically Scrum teams for data science?
Yeah, I think it's critical because right now you have just deep knowledge required in these different areas. From the law, legal perspective, where the AI people aren't going to know, and the data people who know the insides, the particulars of the data, to the AI people who know how the data is going to be used. So I really think you can't roll that all into kind of just one person or one group. You really need a tiger team of deep knowledge from a bunch of different areas.
And then you need some oversight for those tiger teams to ensure that there's consistency across them, to make sure that the solutions are supportable and easy to promote. We see so many organizations that build these models or solutions that they can't get into production, so they never realize the value of it because they're too complicated to support and they can't be operationalized.
I think one of the most important areas are the boundaries, the interfaces between these functional areas. Putting something into production. I remember I ran a small SWAT team that was building some new functionality within the company, but I wasn't going to own the delivery system. So I had to interface my team, my small team, which was protected and doing innovation, had to interface with the existing much larger organization to make sure that what we did fit into what they were doing. And so that partnership was very critical.
I learned of a new role which is coming up just today. It's called DAP. On LinkedIn, there are about 3,000 people now whose title is Digital Adoption Professionals. Sort of a new name being given, new title, which is starting to bubble up on somebody who's cross-functional, and their role is adoption of these models within an organization, irrespective of which department they belong to.
Well, I think that's the fundamental challenge we're seeing in the data science world. Maybe Nick can confirm this, is that companies hire scientists, they build models, and they just can't get any traction for them, can't get them adopted, because that is the last mile. And there's so many obstacles, mostly change management, to getting that. In fact, we have a client right now, and that is the what they hired us to do, is to figure out how to break through the impasse that they found at the intersection of change management and process integration.
Yes, I agree with that. That is a big problem. We hear that all the time. I mean, I think it's a people, process, and technology problem. I think there are technical barriers, meaning the infrastructure that companies have set up for productionizing software applications is not the same as what's required to productionize data science applications. We still see challenges around IT organizations needing to re-implement data science work in a different language. This was data science built this in Python. We got to recode it in Java. That just completely cripples all kinds of agility and speed. One of our customers say they built a new headquarters in less time than it took them to get one of their models deployed into production, which is staggering. And yes, change management and sort of the process side of it's another issue. I think there's a lot of education that still needs to happen if I take a step back, I think data science and IT organizations not tightly collaborating and empathizing with each other and understanding what their needs are and working together is a big cause of the process change. I think IT historically hasn't really understood what data science is and does. And so there's a lot of fear and anxiety that could be addressed if there was more sort of leaning in and mutual empathy. And similarly, I think data scientists often think they're artists and they should be able, they built these great models. Why can't they just put them in production without really grappling with what are the needs of IT? And look, we need these, we're dependent on these for production, mission critical processes. We need them to be, we need an appropriate degree of governance and controls. And I had one IT person tell me, unless our data scientists are going to carry a pager and get woken up in the middle of the night when their models break, they're going to go through our process for how we put them into production. I know I'm not describing, look, there's no silver bullet panacea here. I do think the next question starts to get at some of the solution. So, and I have some thoughts when we get to that.
Well, why don't we go to that next question then? Nick, I'm going to give it to you to address, since you've already brought it up. What pitfalls and trade-offs do enterprises encounter as they try to govern AI/ML models?
Yeah, well, first let me say I'm so glad we're talking about this. And I think as more companies start to depend on more models for mission critical processes, this is going to become a bigger and bigger issue. In preparation for this, I jotted down 3 pitfalls that I think folks should be aware of. The first is recognizing that models are different from software. And I mean that in a really deep way. So a mistake I've seen is organizations think that they can manage and govern models in production through their existing application stack for managing and governance and monitoring. So, we've got, New Relic and we're monitoring the performance of the machines and the memory and things like that. Models are a whole different ball of wax because they are probabilistic, they can drift. There's no notion of a priori correct values. You can't unit test a model. And so, step one is recognizing how different they are and that you need things like the ability to monitor for data drift and performance drift. And that requires a whole different set of skills and technology and internal products, and it's a different ballgame. And that's an example of where I think there's value in educating IT organizations who have traditionally been responsible for managing software assets. The next pitfall I've seen is that in the absence of an IT organization that's really well set up to manage, to monitor models the way they need to be monitored, like detecting data drift, detecting performance drift, that ends up falling on the shoulders of the data scientists. So you end up with data scientists or data science organization who builds these models, and then they're responsible for ongoing monitoring of them in production. And what that does is that sucks up a lot of the data scientists' time. And then the data scientists aren't able to dedicate effort and time to new research and developing new models. And so then innovation slows down and grinds to a halt because your data scientists are spending all their time building custom monitoring solutions for the models they've already put in production. And then nobody's happy because the data scientists don't like doing that work. And then you're not getting new research and innovation out of them anyway. So I'd say, think about how to offload the monitoring management aspects from the data science team. And then the last pitfall I'll share is when companies try to create too much of a separation or a disconnect between the platforms for developing the models and the platforms for managing and monitoring them. Because what you then have is this break where it becomes really hard to effectively remediate issues that you do discover with models in production. And so to put this in more positive terms, I would say, think through your whole process for remediating an issue once you discover it in production. So say you detect model drift. What do you do? How do you fix that? How does that go back to the data science team? How do they critically reproduce the state of the work they did before it went into production, get the original data, investigate the drift, fix it, redeploy it? So you need to think about models have to evolve continuously. And so you need to design your development and production process and technology to function as a closed loop. We get models in production, we monitor them, we manage them. When there's an issue, we remediate, we redeploy. And if you have too disconnected of a technology stack, break that process, and then you end up models go into production, and then they sit there forever, and then they drift, and there's an issue, and no one can fix it or deal with it. So those are my long-winded answer, but those are my 3 pitfalls.
Yeah, to your second point, the offloading of the monitoring from the data scientist, do you see it offloaded to another person or to an automated process?
Well, there have to be people involved, but you can use technology to automate a lot of it. So there are new products. There's a new category of products in this ecosystem right now for doing model monitoring, and that standardizes how it's done. It lets you configure rules, configure notifications. Obviously, we provide some of that capability, but there are other players in the market that do that as well. And what you can then do is you can, instead of having, so the way this goes wrong that we've seen is companies build independent monitoring stacks for every model they have. Well, this model is monitored in this way, and this model is monitored in that way. And each data scientist has their own set of monitoring things they've built up. If you standardize on one platform, you get a lot more leverage and economies of scale. And then, of course, when there's an issue, the data scientist has to get involved because they know the domain, they know the model, they know the statistics. But you don't need the data scientist building and maintaining custom software tooling.
Let me throw out a little, maybe a bombshell here. So Nick, you started talking about IT, and that IT really needs to be more sensitive to how models are different than what they normally manage. Why do we need IT? There's so many new roles being developed, like ML engineer, DevOps, as Kevin was saying. Can we have a separate set of people with specialized skills who know how to do this? Or is it just too entrenched into the production environment if it's a real-time model, for instance, that you can't get away from IT?
I'll weigh in, and then I've been talking a lot, so someone else can chime in too. I do like this line that I shared earlier, like, until data scientists are willing to carry a pager and get woken up in the middle of the night, I'm not sure they're going to be able to do everything. I think here's my hot take. We shouldn't need IT to re-implement models and translate them from Python to Java or whatever. But look, operating production infrastructure is a real skill and discipline, especially at scale in a mission critical environment. And, I don't think you want data scientists knowing how to pull alerts off the Kubernetes cluster about when disk space is getting low and resize the auto scaling configuration. There's a lot of stuff there that I think IT is a real discipline that is hard and challenging, especially at scale. It's just different.
Or do we need like ML specialists within IT who know how to do that better?
Well, the nirvana in my mind is IT really focuses on operating the infrastructure. And then data scientists have expertise in building the model. And then you use technology. There are platforms in the space now that create a great bridge between the two.
And I think you are building up expertise in IT. You find people who are operating machine learning stacks who are different than people who are running SAP and other infrastructure that's mission critical to the company. So you eventually have these specializations that develop, and you take advantage of them.
And I also think that, I think we all might have a different opinion on this, but could you take your current DevOps engineer and have that person add to his skill set how to do this? And I believe in most organizations, that's a training issue that, could happen and somebody could take on and make it work. It's different, but it's also within their skill set. It could be that current positions evolve into this type of position if you already have them and they work.
Okay, so let's go on to the last question here, since we're getting short on time here. Great comments and conversation, everyone. So Sanjeev, I'm going to give you this one. How should enterprises evaluate tools to assist with AI ML governance?
This is a great question, Wayne. When we get into any new project, the first step we do is, we ensure we have the right functionality and there's a business need, we're meeting it. Then the next phase, we start optimizing it, we start tuning it. But the real crux is to get to the final stage, which is an automated, end-to-end, orchestrated process. And so to me, one of the very important pieces that we need to look in these tools is how much automation do I have? And this automation starts all the way from connectors into the data sources, being able to classify, tag, detect anomalies, for data privacy, data quality, all the things we have done, all the way into how am I processing, preparing my data. So that's another important feature: data preparation, data visualization, and then into operationalization of the models. We've talked a few times about IT having to rewrite a Python model in Java. I mean, that's just ridiculous, So we need these tools to help us create these models that run in a Docker container with a REST API interface. I come from data management side. A lot of times we want these models to be exposed so I can call them as a user-defined function from my database. Because I'm already getting the data in. So I'm getting all this customer data coming in, and I have some prediction on customer churn. So I want, as the data comes in real time, I want to be able to analyze that data and tell me, is this customer going to stick or leave? So imagine that real-time integration. So these tools are needed for this kind of automation. And then on top of that, it's really important that we have a clear lineage. So whether it's for auditing purposes or regulatory compliance, or it is for impact analysis, remediation of problems like data drift, I should be able to have a clear view of my lineage in some sort of a graphical manner. So these are some of the critical things that we look for in these modern tools.
I think to add to that, the lineage provenance of the data is key. But the real kicker there is accountability, which is the human accountability. So tools that allow you to assign an accountable party who is on the hook for whatever that decision was that got made, about using the data or building the model or whatever. I think having the person responsible is pretty important to the tools as well.
Yeah, I just want to add one last thing to your point, Steve, and then see what others have to add in the last few minutes. Data catalogs are no longer just data catalogs, they're model catalogs too. So they're cataloging events, models, data, and collaboration becomes really important. Being able to see who the data owners, model owners are, annotating it, introducing like this notion of confidence in the model. So this kind of collaboration is an extremely important feature of these tools.
So Sanjeev, I'm so glad you brought up the point about the evolution of data catalogs here into the model management space as well. I think earlier we were talking about introducing ML AI governance into the broader data governance strategy. So I think particularly when you think about tools, looking for places where there's synergy between those, where does one tool sort of span both those stacks and allow you to affect governance both sort of on the data side and the model side, you can find some real synergy between the two strategies.
Yeah, data is a means to the end. And in my opinion, are decisions and actions which come from the models.
Absolutely.
And another thing I've heard, I think, in this discussion, even in all of the other questions, was make sure to measure everything at every point in the process. Capture all the data and measure all the output. And the tool should allow you to do that and should expose that data to the governance process. That's what seems to be a recurring theme in a lot of this conversation as well.
Yeah, I think that's a great point. It's so easy these days to collect more data, monitoring data flows and instrumenting them to make sure that you're keeping track of what's going on is much easier now than it was just a few years ago. And this data then becomes more data that gets added to the mix. And you can use it to tune performance and to decide what models need to be rebuilt and make a lot of business decisions which drive your analytics. So, I mean, most data scientists love more data. So data about the data is even better sometimes.
With that, Kurt, I'm going to give you the last word here. This has been a wonderful conversation between some very learned people on data science and governance, and I've learned a ton. I hope our audience has. I really, truly want to thank our panelists, and I really didn't do them justice at the beginning because we had those technical difficulties. But as you can tell from the conversation, they have deep experience and knowledge of this space, and I think I'm going to have to listen to this recording a few times to mine all the best practices that came out of it. And maybe we should turn it into a report or at least an article. Kevin and I will talk about that afterwards. But Thank you very much, panel.
Agreed.
And thank you, audience, for tuning in. If you have any additional questions, let us know. I know we didn't get to all of them out there. And please feel free to contact us at Eckerson Group at any time if you have questions that come up, and we'd be more than happy to address them. And thank you again. So have a great rest of your day.
Thank you.
Thanks, Wayne. Bye, guys.
Thanks.
Thank you.